Hello, I'm Lynn Bondurant, and this is the second show of our four-part Moonwalk series. Today's program is called Adapting to a Space Environment. As the title suggests, this episode shows procedures Apollo operators used in order to make sure the astronauts would be able to survive in outer space. This show explains the function of the different stages of the moon rocket, how the stages separate, and what becomes of them. We pick up the Moonwalk story by looking back at some old classic space films that were a Hollywood perspective on future space travel.
For most people, a trip to the planets was easy. All you needed was a 10-cent movie ticket and a nickel bag of popcorn.
Record your speed to 1/2.
I don't know.
Two of Killer Kane's ships coming up fast behind us.
Thanks for saving us. Stand back. You're prisoners.
Prisoners?
Silence! You ought to be taken to...
Uh-oh. Here they come. You better put in reverse, Doc.
Hot flash!
What science fiction in the childhood of the space age could have guessed the shape of reality? The Saturn V rocket. 3 stages, 28 stories tall, with 11 engines as powerful as all the waterfalls in North America combined. Years in the planning, months in the building and testing, the Saturn first stage lived but 2 minutes 41 seconds.
Stages. And ignition.
11 Houston, thrusters go. All engines, you're looking good.
Roger, you're loud and clear.
2 minutes 41 seconds, time to throw Apollo 40 miles up into the sky, and then an empty shell to fall back into the sea.
We got skirt step.
Roger, we confirm, skirt step.
Tower's gone.
Roger, tower.
Neil Armstrong confirming both the engine skirt separation and the launch escape tower separation.
Houston, Apollo 11 and Saturn gave us a magnificent ride.
Roger, 11, we'll pass that on, and it certainly looks like you're well on your way now. 11 Houston, your guidance is converged. You're looking good.
Downrange 140 miles, altitude 62 miles, velocity 10,000.
Mission Control in Houston, Texas had taken over from launch control at Cape Kennedy for the duration of the 8-day mission. The complicated technology of Apollo Saturn evolved from an ingeniously simple concept: lunar orbit rendezvous. This requires a rocket made in many pieces that discards the useless weight of each piece when its function is completed. The flight began with a vertical lift through the heavy lower atmosphere and a tilt to the east. At 6,000 miles per hour, the empty first stage is discarded to save weight. So is an adapter ring and the unused escape tower. With the second stage firing, it reaches 15,000 miles per hour when it too is jettisoned. The third stage places Apollo in Earth orbit at 17,400 miles per hour. When the spacecraft has been thoroughly checked out by the crew, the third stage fires again, its speed now tearing it free from the grip of Earth's gravity. While coasting outward, the command service module separates and docks for access to the lunar module, and the empty third stage is left behind. Apollo loses speed throughout 9/10 of its journey until the moon's gravity overcomes the pull of Earth. Apollo fires in reverse direction, slowing down enough to be captured in orbit about the moon. Armstrong and Aldrin enter the lunar module Eagle, which separates, leaving Collins and the command service module in lunar orbit. Eagle slows still more and brakes to a touchdown on the lunar surface. After the moonwalk, the upper stage of the Eagle lifts off, leaving behind the now useless landing stage, and swings into orbit to dock with Columbia once again. When the crew and moon samples are transferred to the command service module, the lunar module is discarded. The command service module fires itself out of lunar orbit and falls back to Earth. As it approaches the re-entry speed of nearly 25,000 miles per hour, the service module drops away. The command module plunges into the atmosphere, protected by its heat shield. Slowed still more by the heavy lower atmosphere, it parachutes into the sea. The command module, Columbia, is all that remains of the original 3,000 tons of rocket, fuel, and cargo.
Apollo 11, this is Houston, over.
While in Earth orbit, the Apollo crew had less than 2 hours to check out all their spacecraft systems. The last chance to discover and correct any malfunction before the third stage engine is restarted to break them free of Earth. The translunar injection.
We're 10 minutes away from ignition on translunar injection.
Apollo 11, this is Houston. You are go for TLI, over.
Apollo 11, thank you.
Roger that. Apollo 11, this is Houston. Slightly less than 1 minute to ignition, and everything is go.
Roger. Ignition.
We confirm ignition, and the thrust is go.
Apollo 11, Roger.
Guidance looking good. Velocity 26,000 feet per second. Telemetry and radar tracking both solid. Velocity 27,800 feet per second.
Through the window of the command module, the Earth gently slipped away.
Apollo 11, this is Houston. Thrust is good. Everything's still looking good.
Roger.
29,000 feet per second, building up toward 30,000 feet per second.
Apollo 11, this is Houston. Around 3.5 minutes. You're still looking good. Your predicted cutoff is right on the nominal.
Deep space tracking antennas, a third of a world apart, listened to Apollo and spoke to Apollo. As the Earth turned, at least one of them would have contact with Apollo at all times, except when it passed behind the moon.
34,000 feet per second now, altitude 152. $35,000 feet per second. Cut off. We're showing velocity 35,570 feet per second. Altitude 177 nautical miles. At 3 hours 11 minutes into the mission, Distance from Earth, 3,140 nautical miles. The S-4B is reported in a stable attitude for this separation.
Apollo 11, this is Houston. Your go for separation.
Okay, Barrow B coming armed. My intent is to use bottle primary 1 as per the checklist, therefore I just turned day on.
Roger, we concur with the logic.
We're awaiting confirmation of separation.
Roger.
We confirm the separation here on the ground.
Apollo 11, this is Houston. Radio check, over.
The Goldstone station reports a very weak signal. We believe that Mike Collins is now maneuvering the spacecraft in the transposition and docking maneuver, and the antenna patterns aren't too good at the moment. So we have a weak signal strength.
The command service module separated and turned around to dock with Eagle, the lunar module.
Apollo 11, this is Houston. How do you read? Apollo 11, this is Houston. Radio check, over. Roger, we're copying you about 5 by 2. Very weak. Can you give us a status report, please? Loud and clear now, Mike, and we understand that you are docked.
That's affirmative. Hello, Apollo 11, Houston. We recommend you accept the 949. Continue through your sequence of sightings, and then we'll analyze the data afterwards, over. Okay.
On board was a fourth brain, a small computer called Disky, which solved problems and helped with a long sequence of systems checks and data exchange with Earth.
Houston, Apollo 11, star 40 has just disappeared now in the sextant. Could the trunnion angle 47 something be a little high? Stand by. Hello, Apollo 11, Houston. We'd like you to press on to star 44, over. Yeah, roger. How many marks?
They found their way across the sea of space, navigating by the same stars that guided Columbus to shores unknown.
11, Houston, we copy. 2 good marks, over. Okay. Okay, drug removal is coming next.
3 days falling to the moon, free of the gravity of Earth. No up or down, no day or night. A sense of stillness while traveling at the speed of a meteor.
About how long it'll be before you start closing the limb back up, over.
An invisible speck in the night, somewhere between here and there, constantly monitored from Earth. Within this tiny spacecraft, a temporary Earth environment, warmth, air, food, water, everything necessary to sustain life. Beyond these fragile walls, nothingness, absolute cold, an end to life. The most important function of the spacecraft, life, was also monitored constantly through telemetry, the heartbeat and breathing of each astronaut. Although each breath was 30,000 feet farther from Earth than the breath before it. Should one heart flutter, it would at once be a matter of concern to millions worlds away. Unlike any other place man had traveled before, space could provide him with nothing. It is a vacuum, devoid of every element needed for life. To send man into this nothingness, to protect him, it was first necessary to define him. What is the human machine? How does it function? What is the nature of its nervous system? Its respiration? Its circulation? Digestion? Sight? Hearing? Balance? Its endurance? what gases to breathe should he take with him from Earth? What atmospheric pressure suits him best? Is it possible to give him a more efficient atmosphere for space travel than nature provides on Earth? The moon is 250 degrees hot in sunlight and 240 degrees below zero in the middle of its night. How long can a man bake or freeze? What protection will he need from this inhuman environment? What strains will the heart take when the pressure of gravity is removed from the limbs? What protection will the body need from sudden deceleration or acceleration? Man's sense of direction, speed, and balance are easily fooled. Can his mind be trained to ignore false signals from his senses? We were defining the physical man in absolute terms. Once we knew man's limitations, we could build him an artificial environment for space travel. Columbia, the command module, was a supreme achievement of the technology of its age. It was a mini planet, complete with its own environmental control system, telecommunications, electrical power, guidance, navigation, stabilization, propulsion, reaction control. It provided hot and cold water and removed carbon dioxide from the air. 3 men could live here for more than a week, eat, work, sleep, shave, exercise, and listen to music. It was micrometeor-proof, burn-proof, and seaworthy, and it could tilt itself in any direction. In short, it was the most intricate and sophisticated machine ever made by man. As for man, however, we're stuck with the original model. All we can do is add an outer layer of things he does not naturally have. Space medicine showed us where man is vulnerable, and we learned to compensate for most of the weaknesses with technology and careful workmanship.
I made boxing gloves before I came here, and the fact is I was an experienced sewer, but I had to learn all over again because it was completely different from what I had sewed before. This was getting right down to a 64th of an inch, and where I had sewed before, you just sewed on a production line. And this here is quality more than quantity.
Like, we always think our job is the hardest. Whatever we're doing, we got the hardest job. But when they say, well, go there and maybe do so-and-so, well, you'll find out that job is harder than yours. And then a lot of times we're sewing or making things, and maybe the girl next to you, she's doing the same thing, but we never see the suit put together. One don't know where this part goes, or the other one don't know where the other part goes. Like the gloves. If they would give you a glove to sew, you wouldn't know where to start.
Well, when they're up there in space, you know what parts you've worked on, and you just say, well, I hope that part don't fail because I'd feel it was my fault if it did.
My sentiment is what Hazel said. Well, I was just wondering if my pair of gloves was what he had on.
Right, if you make a mistake, if you don't admit it, you have to think about the astronaut too. If you make like a needle hole in the bladder or something like that, well, if you don't admit that, that would be on your conscience all the time, seems to me. Because I remember Armstrong and all them used to come in, and they would look around and see what we were doing. And once in a while they'd talk to us and sign we'd get them to sign their autograph. Some of them were real comical. We got a kick out of them. We all wanted to talk to them, I guess. I remember one of them going down the aisle, everybody looked at him, afraid to talk. I said, hi, buddy.
Oh, I'd love to go into space. I think it would be really thrilling just to get in there and just blast off.
I'd love to go to space and just live there.
Every day you get up, you come to work, you go home, you clean house. If we go out there, there's no house, no kids, no clothes. I like to ride in an airplane, and I think I'd like to go into space. And I'd like to wear our own suit that we make. I think I could depend on it.
After body electrodes have been attached to monitor heartbeat and breathing, the first items of clothing are the water-cooled underwear and a urine collector. A spacesuit is basically a sealed bag of atmosphere, a stiffened balloon, pumped up to counteract the vacuum of space. It might be called a one-man spaceship of the smallest possible dimensions. The pressure suit has to guard against extreme temperatures, hard radiation from the sun, and tiny meteorites. Yet, it must have the flexibility to allow man to function as he would in his natural Earth environment. The backpack cleans and cools the suit's oxygen. cools and circulates water through the water-cooled underwear, and provides radio communication. Over the pressure helmet is a clear visor, then a gold-coated visor to protect against micrometeors and solar radiation. The final test was, how would the suit work in the silent, weightless world of space? Weightlessness on Earth can be experienced only underwater, or in an airplane following a parabolic flight path. The only true test was in space itself. No up or down, no day or night. Only the slow creeping of the harsh sunlight through the windows as the spacecraft rotates to keep from getting too hot on one side, too cold on the other. They carried with them the biological day of the Earthling. 3 meals, a snack or two, 8 hours of sleep. Time to work, time to relax, time to reflect. 3 days, falling upward to the moon.
Now the stage is set for man to venture onto the moon. The many space simulations proved to be most effective. Now it is time to take the knowledge gained from these tests out into space. And this is exactly what happens in next week's program called One Small Step. I'm Lynn Bondurant.